I'll start. My name is Freddy Rangel. I am a software engineer out in San Francisco at a company called HelloSign. So I work with legacy React applications. We've been using React for roughly 2 years, a year and a half, 2 years at this point. So I'm seeing some pretty old React code, which is really interesting. I'm also the author of React Under the Hood, which I published, I believe, about 6 months ago. And I'm currently working on a new book called React the Good Parts. So that's mostly what I'm up to. Swizec, do you want to? I guess I'll pass it on to Swizec.
Yeah. I guess I'm Swizec. I currently live in San Francisco. I'm originally from Slovenia. And actually, I think this year people actually know where Slovenia is for reasons. But that's pretty much it. I wrote a couple of books. I write a blog. Usually I just tell people to Google me because that's easier than giving an introduction. And I think in the end we'll have more time for Q&A, and we're going to give you links to the stuff we want to share. And I guess we should just start with the presentation, right?
Sure.
Okay.
Yeah, go for it. I'll just make sure it full screens when you've got it up.
Perfect. So this presentation is not going to go into that much detail. I'm just going to show you why you'd even want to use React with D3 to make visualizations, because I feel that that's sort of what trips people up when they start. Like, you already have D3, why would you even bother with React? And one thing you have to know is that everything you see in this presentation, except for the slides, of course, is written in React and D3. So for instance, that particle generator you see in the background, that's React and D3, where it's just a list of little dots that moves around. But to start off with, I think we can all agree that D3 is great. I can't really see the chat room right now, but you guys have said that you've used it before. So hopefully you agree that D3 is amazing. It does pretty much everything you want. It's used by everyone. It can do everything from simple visualizations like bar chart and line graphs and things like that. And it can do really complicated things that show up in New York Times as like special features and things like that. It's really great. It really does everything. So why would you want to add React to that? Why would you need an extra library to make things even more complicated, to make your life kind of harder, right? The thing is, you can think of D3 as a jQuery for data visualization. It does everything, but the more your visualization grows, the more complicated it becomes, the harder your life becomes. The harder it is to debug, the harder it is to see what's going on. And I mean, let's not even get into the situation where you have more than one person working on the same code base, and you have like less experienced people trying to fix your bugs, and you have more experienced people trying to tell you that, hey, you're doing all of this wrong and you should do it a completely other way. And I've seen D3 visualizations where it's just a 500-line mess of code. It's just a wall of code, and you keep reading it and you don't understand anything. So the reason you want React in your data visualization is the same as why you'd want React anywhere. It makes your code easier to structure, which in turn makes it easier to understand and to work with. And more importantly, it makes it easier to work in teams. So there's basically 4 aspects of why React is great. The first is componentization, which is turning your code into discrete components where each one does one thing, and then you can focus on that, which in turn makes it easier to test. And yes, I have a bird, so if he squawks a lot, don't be alarmed. You can sometimes hear him like a block away. Anyway, you have componentization, which is amazing. And then because you have componentization, you get easier testing and debugging because you can focus on specific parts of the code base. And then React gives you some fancy diffing algorithms, which make it so that you don't have to worry about deciding what to update, what not to update. You kind of just render stuff and it works. I'll show you how that works later. And finally, you have hotloading, which honestly is not just about React. It's more like React or some other tooling, but it works really, really well when you have a giant data set that takes a couple of seconds to load, a couple of seconds to render, and all you want to do is change some styling and things like that. That is a lot easier when you can hot load your code and it doesn't refresh your browser. But in reality, it all comes from componentization. That's really the main benefit. You have components, and then because you have components, it's easier to test and debug. Because you have components, you can do diffing algorithms because React understands how your code fits together. And because you have components, you can dynamically hot load code into your browser without changing the other parts of code. But componentization itself has some subpoints. Yeah, I guess subpoints is a good word. The first thing you get from components is you can do declarative data visualization. I don't know if you've ever experienced this problem with D3, or rather, D3 also claims that it's declarative, where the idea of declarative code is, I scrolled forward too quickly. Okay. The idea of declarative code is, how should I put this? It's kind of hard to explain declarativeness from scratch, but the idea is that instead of saying how you want something to happen, you just say what should happen. You say, I want a button, I want this, I want that, and your system kind of takes care of it. Takes care of it on its own. Like a good example for that for web developers is HTML, for instance. You don't tell the browser how to render a link or how to make a div. You just say, I want here to be a link, I want it to be in a box, and so on. And D3 kind of tries to do that, but it's not that great at it. So one of the things you can do with declarative data visualization is things like this animation. It looks kind of complicated, right? You have an alphabet and it moves. When new letters show up, they kind of move down, they move left and right, and so on. Like, a lot of things are going on here. And it's kind of hard to wrap your head around how you would do this manually. But with React, what you actually do is you just say that an alphabet is a list of letters. So this is the whole alphabet component. And I dimmed out the parts that aren't that important. So let's just focus on the render method, which, as you can see, returns an SVG grouping element. That's the G right there. And then something called a React transition group, which helps with the animations. And I don't really want to go too far into that right now because it's not that important. And then the core part is the 3 lines in the middle, where all you have to do to render the alphabet is just map through a list of letters and render a new letter component for each one. And that's it. That renders the whole alphabet. And then to animate it, well, make the alphabet an interval where every second and a half, you just generate a new alphabet. The code looks kind of weird, but if you look at it closely, you'll see that shuts and sorts it alphabetically. And that's it. When you do that, you trigger a re-render in React with this.setState. It triggers a re-render and essentially calls your render function again. And the render function then just very naively goes through the new alphabet and renders the new letters. And then because of the diffing algorithms and the stuff that happens in the background, all the fancy animations happen. Every letter knows that it's like, oh, hey, I'm a new letter. And if I'm a new letter, I should animate to come down. If I'm an old letter, I should animate to become red and go further down and to move left and right, and things like that. It all happens declaratively. That's the point I'm trying to make. Each letter knows for itself how to animate, and the main alphabet component just naively renders them and throws them at the page. Things just happen from there. We'll talk more about diffing algorithms and about that stuff later. So from that, we come to reusability. I kind of already showed it with the letters, where you have a letter component that you just reuse multiple times with different properties, and it renders different letters. But take, for instance, something like this. This is a visualization of 4 different salary distributions based on what kind of job you have. It compares, the data set is from H1B visas, And that's not really that important. What's important is that you have 4 different histograms rendered on the same page, and they show different data, they show different axes, different everything. And I know this is, as a visualization, this is really bad. Don't think about that too much. It's the histograms aren't aligned, they don't have the same range. The axes are hard to read because it's apparently very difficult to rotate labels in SVG. I don't know if you tried, but SVG rotations are really confusing. But it gives you an easy way to see that engineers have a broader distribution of salaries than, say, developers, which are all on the lower range, and programmers are on the higher than the engineer range. But none of that is that important. What's important is that this is how I was able to render that. At one point, I created a histogram component, and then I can just dumbly reuse the same histogram component to render a histogram literally anywhere in any visualization. And that's really the power of components. You have these complex pieces of functionality where all you have to do is just say, hey, I want a histogram to be here, or I want a letter, or I want this or that. And the only difference here is that each histogram gets a different data set. You can see that the first one gets the entire data set, the second one gets engineer data, and so on. And then they have different properties for where they want to render. And I know I probably shouldn't have dimmed all of that away, like the properties and stuff, but all I wanted to really show you here was that histogram, that you have these complex pieces of functionality that you can just render anywhere. And if you structure them correctly, if you follow the guidelines of this package with styling and stuff like that, then you can literally reuse this anywhere. No matter how many times you render it, no matter where you put it, no matter the environment, it always renders the same thing, which is really powerful. And it's something that D3 doesn't really give us. It tries to give us that, but it makes it really complicated sometimes. Now, you kind of already saw this with both the letter, the alphabet example, and the histogram example. The benefit of another benefit of having all of these components is that you can see the structure of your data visualization at a glance. Like when you look at this, for instance, you immediately know that, hey, this is 4 histograms. When you look at this, you say, oh, hey, this is just a list of letters. You immediately see what's going on. Now, if you compare this to D3, this is a pie chart example in D3. This is from, if you Google D3 pie chart, this is the first code shows up. Like it's the first hit. It's from Mike Bostock. He made this as the example of how to use D3 well. And I don't know about you guys, but I have no idea what's going on here. It looks really elegant. It looks nice. It's very well structured, but it's really hard to see where the pie chart comes from. Like what is actually going on here? You have a bunch of setup code, and then you have some weird stuff in the bottom. And really, the important part in this pure D3 example is the bottom. It first uses D3 CSV to load some data, and then does some select magic to add arcs, which is like what it says is, hey, let's add for every. Actually, I don't even know how to read this. I was able to read this like half an hour ago, but now I forgot. And that's really the problem. Imagine giving this to somebody who's a junior on your team, or just somebody who hasn't done D3 before. It looks powerful, it looks elegant, but it takes really long time to understand what's going on. Like even when you're very experienced with D3, even when you've done it for years, like when you've written books about it, it's still hard to understand what's going on here unless you really sit down and look at it and think through it and see and really try to understand. You can't just look at it and be like, oh yeah, that's what this is. And this is a pie chart example I built in React and D3. It's a bit more code, if you look at it, sort of. And I've taken out a lot of the surrounding code, like the parent component that renders this and things like that. And honestly, it still looks a bit like magic, But on the left, you can see that you have a pie chart component that creates a pie chart. If you look at its render method, its return statement in the middle, you see that it's just a list of labeled. It goes through pie data and returns a list of labeled arcs with some properties. And then on the right, you can see what a labeled arc looks like. It just extends the arc, and that does stuff, and the arc itself does some other stuff. I don't really want to go into details of what. Don't hide the camera, bird. I don't really want to go into details of what's going on here, and I hope you're not trying too hard to read this code. But the idea is that you can immediately see that a pie chart is a list of labeled arcs. A labeled arc is just an arc with some text. Like, let me highlight it. A pie chart is a list of labeled arcs, and on the right you see that a labeled arc extends an arc, and then it uses super.render to render an arc and add some text to add the label. And I don't know about you guys, but arc now seems like a really weird word. I've said it too much. But that's the point. You get these structures, you can read, you can immediately see what's going on, even if you don't understand the D3 magic behind this, even if you don't know how React works. If you can read basic HTML and you're kind of comfortable with JavaScript, you can essentially see what's going on. You can look at this and you know, oh, hey, I have to go there to explore further. I have to look into that component if I want to see how that part works. And that's really powerful, especially when you have team members with varying levels of experience. So that's componentization. It gives you structure at a glance. It gives you those other two things. It was structure at a glance, and wow, I'm blanking. Anyway, the next point is that because you have this componentization, you get better testing and debugging. Now, I could make an entire new presentation about that, so I'm going to avoid talking about it in depth, but I think we can all agree that if you have well-designed components that only rely on their properties and don't do too much weird stuff, and by weird stuff, I mean they don't break abstractions. I'm not sure if that's... You can look up leaky abstractions if you want to know more about the problem of breaking abstractions. But the point is, you can essentially ask somebody on your team to say, hey, we need like histograms, develop a histogram component for React, and then you don't have to worry about it anymore. You just reuse it there. In theory, with D3, hard to test and hard to understand because you still have to know everything around them that's going on. Whereas with React, you can just focus on one piece of the code base at a time, which makes your life a lot easier. So now we come to the fun part, the fancy diffing algorithms. React comes with an algorithm that was inspired by games. I don't know. When I was a kid, when I first started coding, the main thing I wanted to do was build video games. And I built many of them, and they were crap. Like, they were really terrible. They were not good games, but I had a lot of fun. And one of the main things you learn when you're building games is that it's a really, really big problem when you have hundreds of little elements on the page that all have to move. They have to know to go left, to go right, up, down, whatever. They have to know how to interact and things like that. And it gets really, really difficult to handle all of that. It becomes it's like a huge problem to keep all of that in mind and think about it. So what game developers decided was, let's just forget about all of that. Every time the state changes, let's just clean the screen and render from scratch. So what you do is every 60th of a second, you just throw everything away, change some data model, and then re-render everything from that data model. And React helps you do that. So what I was able to do last year for a talk was build a simple Space Invaders clone that is this principle. All of the entire game that you see here is just a giant object with state where, like, it's an object where you have enemies, you have bullets, you have the player, and it's a mishmash of X and Y positions and vectors. And then every 60th of a second, I just update the game state, and that triggers a re-render, and then React is smart enough to figure out how to do that. The thing here is that if you were actually re-rendering everything every time on every screen refresh, it would become really, really slow. So what React does is it only re-renders the elements that actually changed, rather than everything. And that's really the powerful thing here. You can just trigger changes. You can trigger changes on your DOM, trigger changes on your data model, and React handles the rest. Only the things that actually changed get re-rendered, and that saves a lot of computer cycles there. Another great thing here, because it's too much, but the idea is that lifecycle methods give you like hooks or event hooks into the lifecycle of a component. Every time a component comes into the screen, or it changes, or something happens, you can do stuff. You can like recalculate data, you can in data, you can load data, you can even do animations on like the alphabet example. All it had to do was, if you're a new component, then animate like this. And it worked from there. Everything worked automatically. So the diffing algorithm gives you forget, you change stuff and forget about it. Everything happens on its own. And it gives you lifecycle methods so that you can do stuff when your component changes. Wow, Bird is getting fed up with me. Now, the last part is really cool, and I'm going to be really quick about it, is the hot loading. It looks a bit like this. You have a visualization, and it looks silly on a simple example like this, but imagine that you had thousands of data points, and it took a couple of seconds to render the initial state. And every time you change something, you can see me changing parts of the code, and the visualization changes on its own without having to refresh, without losing state. Changes, it doesn't re-render that. It actually does re-render. That's the fun part. It does re-render, but because you're using lifecycle components to load the data, you've only loaded it once. So once you re-render, the data is already there. The state is already there in your code, and you can just focus on tweaking your stuff without losing too much time on waiting for giant re-renders. So that's what React gives you: componentization, easier to understand code, fancy diffing algorithms, and hot loading, which is amazing for data visualization. Like, you cannot believe how much my life is easier now that I can use hot loading. And that's the main point. React makes your D3 better, and it makes your life easier. So I think that's it from now. For me, we can go to the questions now.
Oh, by the way, I'm not sure if you can hear me, but great presentation. You really missed a lot of the great comments on the side about the bird. A lot of great jokes. It was awesome. I love these comments.
Cool. I have no idea how to stop sharing my screen.
I think that's how it works. But we're available for questions.
Cool.
We did have a few in the Q&A.
If you want to start picking through those, I can click the button and mark them as being.
Okay. Should I? So the first question is, what are some general things to be aware of with how d3.js and React may not play nicely with one another, especially with re-rendering? And I kind of showed you that in one of the code samples. I didn't really explain it in depth, but the problem is that D3 uses internal state for its objects to decide what to do, and React really hates state. So what you have to do is you have to kind of manage D3. I usually do is I use the lifecycle methods so that when my component is initialized, when it first comes on the screen, I initialized my D3 objects, and then every time the properties update or the state updates, I just use the getters and setters from D3 to update the internal state of those D3 objects so that I don't have to keep re-initializing them. right? Is that how you do it, Freddy?
Well, that's one approach. I think the other approach that I also saw in your book, because I think I bought your book about a year ago, was using React, and I think this was what you did in the presentation as well, is using React as the presentation layer, as well as like using it to manage state changes, and just using D3 for certain utility functions like scales and uploading CSVs and that sort of thing. That's pretty good with like static stuff, but once you start adding animations, that's when you really want to do the other approach, where you also update state in React, but also simultaneously update it in D3.
Mm-hmm. Exactly.
That's a good question. Let's see, what's your setup for hot loading? We don't use hot loading at HelloSign, just because, like I said, our application is not that old, but for React applications, it's still fairly old. We want to implement hot reloading at some point, but there are certain things that we're trying to implement, like Redux, for example, that sort of thing. We have our own custom architecture that's very similar to Flux. But certainly it's something that we had to come up with before we had Redux. What about you, Swizec?
Yeah, I have the luxury of mostly using React on toy projects, so I can use fancy new stuff. I don't have to worry about backwards compatibility. So what I do is I use Dan Abramov's boilerplate to start with, and what he sets up in there is Webpack hot loading, or rather, you use Webpack for compiling, and Webpack has support for hot loading, because actually, I don't know how it works. It knows when a part of the code base has changed and can render it into the and you can it hot loads the code into your browser, because you use Webpack as actually, it's kind of complicated to explain. The simple part is you use Webpack for the hot loading and code compiling, and then there are some NPM packages that you have to use to make React play with that very well. I think it's easiest if you just Google for a boilerplate project. There we go. Somebody linked it. Mm-hmm. That's what I use, and it works really well.
I'm seeing one question here that I find really interesting. Any experience with combining D3 and React Native? No. I don't know who would. I know the people over at TaskRabbit use React Native fairly heavily, and they do certain, they use like certain mapping libraries and stuff. I wouldn't be surprised if they also use D3. But in theory, it should be like, actually, I don't think it would work because you need SVG for D3.
You don't need SVG for D3. You can use D3 as just the data layer to calculate properties and stuff, and then you can render into anything. That's actually one of the benefits of using React with D3. That's one of the benefits of using React as the presentation layer. In theory, you could just change the renderer and render to Canvas, render to native WebGL or whatever. That's part of the point. You don't use D3 to access the DOM directly. You do that with React so that you can then you become agnostic to things like where you're rendering to. In theory, you could even render on the back end.
Right. I'm seeing one question that was related to the first one we took, which is the top one here. In complex D3 charts, where's the best place to store state? D3 has natural data binding, React has internal component state, and many complex projects now use React stores, etc. How can I put this? I try not to go overboard with Redux stores or just Flux in general. If there's some kind of state that is component state, like I end up leaving it inside of the component and try to manage state inside of the component as long as possible, unless that data happens to be application state. So ultimately, I guess the answer comes down to, well, it depends. it really comes up to your best judgment, whether you feel like this data should be managed on the Redux side or Flux in general, whatever it is you're using for your data model, or in component state. But generally, I like to take state out of D3 as much as possible, because one of the benefits of the whole React Redux ecosystem is a clear understanding of how state mutates over time, making it easier to debug and reason about your components when they break, which they most likely will, right?
Yeah, exactly. I think the easiest way to decide between what should be a component state and what should be a property is it should be a property if you want to control it from the outside, like positioning or things like that. And it should be a component state if nobody else cares about it. Like a good example are toggles, where you want a toggle doesn't really have to come, the true false doesn't have to come from outside. It's good enough as state. Yeah, I think it's just experience. Once you do it a lot, you'll see what works best, and you'll quickly run into problems when you do it wrong.
Let's see. Do we want to cover one more question? Can we see your bird before we all sign off?
Yeah, I think we've done that. There we go.
Okay. I have 3 cats, and they've been behaving today, so that's good.
I guess just one of the questions that I'd want to pick up on is any of this code going to be accessible or not? Obviously, if it's difficult, then probably not, but it seems like a reasonable question.
All the code is actually on GitHub.
Okay.
If you go to github.com/myname, you will be able to find it. It comes from several different projects, so it might be spread out, but it's all there, and it's all publicly available. And for a lot of it comes with blog posts as well. So if you just Google Swizec and D3, you should be able to find stuff.
Awesome. Cool. Well, thanks, guys. It's been absolutely great. And yeah, it looks like everyone's really enjoyed it. The chat's been really good. If anyone wants to ask any more questions in the chat, then I'm sure, if anything comes up in the next couple of minutes, you'll pick it up. But yeah, not much more to say, but another good session. We haven't got another one planned just yet for next week. So yeah, if you're reading JavaScript Daily or reading JavaScript Weekly or whatever, just keep your eyes open. I guess actually this is a good time for you to mention the things that you're doing as well, because we've linked to your React and D3 workshop that you're doing, but maybe you could explain just a little bit more about that.
Yeah, so we're doing a React and D3 workshop on June 5th at Microsoft Reactor here in San Francisco. So anyone who is here is certainly welcome to come join us and learn about React. It's a full-day workshop taught by myself and Swizec. And also, I think the link went out, right? But you can find it on Eventbrite. Search for React and D3, and it'll be the first thing to come up. Yeah, sorry. Maybe we'll come over to New York at some point. we're planning to do that. And Swizec also has a new edition of his book, which you could tell us about.
Yeah, I'd just like to add about the workshop. Every time in this presentation where I said I'm not going to go into that, in the workshop we are going to go into that. And we're going to talk about all the details. And by the end of it, you will be able to do some really amazing stuff with React and D3. If you can't come to the workshop, you can also get my book, which is on swizec.com/react.d3.js. It basically teaches you what I've already shown you here, goes into a bit more detail. The main benefit is I think it's still the only book on React out there that uses fully ES6 code samples. And there's also some video to go with it and things like that. You should really just go to the landing page and check it out. It's pretty great. I'm very stoked about it. And I do keep publishing updates where if you get the book now, you will get updates to the book for free.
Andy asks, do you go into testing in your book?
I don't go into testing in my book yet. That's one of the things that I've been meaning to add, potentially as a separate book completely. But what I do is I do weekly live coding where you can come talk to me, I take any questions there, and you can talk to me and you can watch me code, usually React and D3 stuff. Right now, what I'm going to be doing for the next couple of Sundays is like a behind-the-scenes view of the workshop where I'll be developing the example that we are then going to show you at the workshop.
Oh, cool. So yeah, I'll get links off of you, and then what we'll do is I'll include all of the links in the email that goes out with the recording. So yeah, people who've asked about the recording, there will be a recording. Unfortunately, there will be a few little gaps in the video and speech, just as there have been, throughout the thing. But yeah, there'll be a recording. I'll be sending that in an email to everyone, and we'll include all of the links that you want to include. So yeah, look out for that, everyone. Perfect. So yeah, I think that's it now. I can't think of anything else unless there's anything you want to close with at all.
No, I don't think so. Thanks everyone for showing up. Much appreciated.
Awesome. Cool. And will you just hang around the chat just for another couple of minutes, just in case anyone's got any questions or wants your links or anything like that?
Sure.
Cool. Thank you for attending, everyone. Thanks, guys.
Thank you.